Now, the society or the industry is not interested in how much knowledge you have got in signal and systems, how much knowledge you have got in VLSI. But what it needs is, can you give a different type of a smart TV? Can you improve on the existing TV? Can you make a digital satellite system, which can take on more and more communication load? Can you make a radar which can detect a vehicle? Today, vehicles, self-driven vehicles are coming into the market in large numbers, and the heart of this are the sensors or the radar. So they need to know what is in front, what is in side, left and right, then what is in back. Who will have this? Who will give this information to the robot or the machine which is driving the car, which is the radar? So if you see how the industry is progressing, really, if you take, there are four major industries which account for 70% of global money spent, whether it is in R&D or whether in the manufacture. The order of money invested in this four industries, first comes the aircraft industry. Today, aircraft cost not less than 2,000 crores, a civilian aircraft, or more than that. So, if you have to have 1,000 or 1,500 aircraft flying around and conveying or transporting the passengers, not only the passengers, but the goods, then you can imagine how much is the manufacturing industry in which aircraft is there, how much is the money that is there, that is concentrated there. The second industry, that is, if you see the James weapon systems, radar is going to occupy the second place. That is military and civilian radar. Today you see a Rafale aircraft which has got 20 to 25 radar systems of different varieties, costs you not less than 1,600 crores. Why so much of money? It's because the complexity has increased. The complexity of war has increased. There is no other way a country can be protected when we sitting at our places, happily sleeping, happily eating, without bothering what is happening at the borders. It is because of the technologies that are involved and the people behind them. So day and night, this lot of R&D money, research money is spent on these systems like radar systems. And many people have got a misconception that radars are only used for the military systems. Today, as a modern civilian man, you cannot live without a radar. Why is that you cannot live with a radar? If I want to travel from one place to another place, especially in the advanced countries, most of the transport, most of the passengers travel in flights because to cut down the time. So if you see a New York airport, at any time, there will be 400 to 450 aircrafts flying around to get to land and take off. You don't have 100 or 150 runways there. At the maximum, you may having 8 to 10 runways. Who will control this particular aircraft? How do we know which aircraft belongs to which nation, which company? Does it belong to TWT? Does it belong to Air India? Does it belong to BOC? Does it belong to Atlanta? Who knows this? All this is known to the operator who is sitting at the ATC, air traffic control, a small room in which all this information will be presented to the operator to control the traffic. It's a very complex thing. So he should know which aircraft is where, And these 400 aircraft or 450 aircraft flying, they should not clash, because the pilot will not be able to see. There is a haze, there is clouds. He will not be able to see anything. So all this he does is done by the radar. Then the third industry, I'll come back to that once again, the satellite industry. Today, satellite communication has grown from the village level to city level to a state level to a nation level to international level. It's all because of the satellite. Today, you are talking to the, even in space, you are sending radio signals. It is all because of the satellites. So satellite is the third industry, which is taking huge amount of our expenditure, that is their budget expenditure from all the governments of the globe. Fourth industry is the automobile industry. So the automobile industry is expanding like anything. We are all talking about the robot-driven cars, self-driven cars. Nobody needs to be there. How is it possible? How is the vehicle be able to see what is there in front when it is going at 200 to 250 kilometers per hour? How is it possible? All is possible because you have the radars. Unfortunately, you can have the same information also through the IR, but the IR is in times of rain, in times of clouds, in times of haze. It will not be possible. Attenuation will be so much, you will not be able to get proper reflections, which are called the echoes. But radar does not have this kind of a problem. It can penetrate through clouds, it can penetrate through the haze, it can see in darkness. So the importance of radars are unique because unfortunately in our country only, the radar industry has not grown. Students who want to go abroad, there is immense opportunities to work to industries in this particular radar system, and they are the highest paid people: radar designers, radar developers, radar maintenance people are the maximum paid people, because it spends so much of money. Radar systems are spend so much of money. So then you have already told what is so much of importance of radar in the civil industry. First, I will talk about the civil industry, then come to the military. When you're talking about the civil industry, this airports, I told you that in New Delhi, at any time you go, of course, now it is COVID is there, you will have minimum 100 aircrafts circling around the airport to get permission to come down. And equal number of aircrafts will be waiting for permission to go up. So touchdown and touchdown, it becomes a very, very complex thing, and government is all in all countries, even smaller towns are being equipped with this kind of an airport. So radar is a must. Radar is going to be a must, and industry is going to increase or enhance its spending. Then most important thing is, many of us do not know, we are all thinking our TVs, our smartphones, our all other laptops, everything are coming through somewhere, but all things are coming through the commerce is taking through the ships. These ships travel in high seas because the transport charges is less. So in these high seas, if so many ships are traveling, The visibility is poor, especially in countries like Europe, where hail, snow, rain, cyclones, etc., will not allow the ship, the person who is driving the ship, to see in front or in sides. So therefore, it becomes imperative for him to employ the radars. So hundreds of ships will have to be safely berthed. If you go to Bombay or Calcutta seaport, ships coming even in night. How is the person there is able to get in these ships without danger, without collision, even if it is night? So he will be allotted maybe, let us say, some 20 to 25 feet of berth. He has to straight come onto that and berth there, come into that line there. So without the collision, he has to drive his ship. So the radars are the only means of guiding the person there, the ship's person there. And to tell you, this is just for the sake of in 1800 and something, 50 or sometime, you know that there was a ship Titanic. I think many of you also might have seen the picture Titanic along with that love story also is there. Almost 80% of the population, especially the students, would have seen this particular picture. Picture on Titanic. So the Titanic ships at that time was built. It is a luxurious ship. It was built at that time. There was no radar. So therefore, unfortunately, this ship traveling through the storm goes and hits an iceberg. Icebergs are the islands where ice is formed. The person driving will not be able to see. So it went there and got this total destroy was there. So many rich people died. It's all happened because at that time there was no technology, there was nothing known about the radar. Radar came into picture only in the Second World War. Second World War. I will tell you why, how it came into picture later. Then another important thing is today we keep on looking at the weather. Should I go out? Should I go in car? Will it be raining? Or do I get sit into the storm? All this information, who is giving us? When you open your mobile, you will see the weather report. When you talk about see with the TV, they will tell you. When we talk about the cyclones, when we talk about the storms, where they are going hitting the coast, this is required for our revenue people so that they can evacuate people from being killed by the storms or the cyclones, so that at least life is preserved, life is a endangered life is preserved. In probably you may not be knowing that long time back when N.T. Ramarao was our chief minister, there is what is called a big cyclone came. Thousands of people died. It is called the Dibisima cyclone. It was all because we were not having any prior knowledge of where the storm is going to hit. So from that time onwards, we have all the coasts, all our coasts are equipped with the weather radars. Then today, agriculture also is monitored. The crop monitoring by pests, weathering, etc., are done by the radar. It's a complicated type of science, but radar is they take the radar pictures and try to predict and give the necessary warning to our government people to use whatever pesticides are there, things like that, and give it to the farmers. Then Coming back to the last but one, this is height of aircraft is very, very important, and helicopters are today flying in large numbers, especially the helicopters also. In European countries, helicopters are manned by large number of private companies. They should know the height of this helicopter when they're flying. This height of the aircraft is known by what is called the radar. It is called FMCW radar. It's called a height finder. So, to give a, of course, a tragic example, our Chief Minister, Sri Rajasekhar Reddy, untimely death is now attributed, it's found that it is attributed because it's the helicopter in which he was traveling, the altimeter was not working. And he was flying in a Nalamala forest where it is lot of hills, it was raining, it was totally dark. The pilot could not, the helicopter pilot could not see what is happening. So unfortunately, Rajasekhar died, and whether it's a thankful thing or unthankful thing, we got the Telangana state. If he had been living, we don't know whether the history would have been different. Okay. Then lastly, in railways also, today we talk about railways, the number of railways that are traversing through our country has enormously increased. We need to prevent them collisions, especially when it is dark, when the railway driver is not able to see. Then this is all because it is possible to the anti-collisions radars are mounted on the railways. Then, as I told you, automobiles, the latest craze, so much of money is being put on the research for this getting this autonomous vehicles. They are called autonomous vehicles, robot-driven vehicles, or driverless vehicles. Today is the next 15 to 20 days. All students who are at this age will be able to possess these things because the technology is again related to the radar. Without radar, you cannot see in front, you cannot see back, you cannot see left or right. The robot, the machine, which is supposed to drive you at 250 kilometers or 300 kilometers per hour, will not be able to perform its job unless radar functions properly. And of course, the observation of extraterrestrial objects or projects, galaxies, space travel, etc., is only possible with this radio transmission. Radars are the main equipment that is necessary. And to tell you, you youngsters, if you are monitored, if you are caught by the police for your speed, for increasing your speed, it is how do they know your speed? It is because the police are using a radar. It's called the CW radar, FMCW radar, which monitors your speed, the actual speed of the vehicle in which you are traveling. So therefore, it's because of this FMCW radar, all of us, if we are traveling above a speed, we are being caught and challaned. It's a police radar, it's called the police radar. Then today you are seeing some the terrain maps of Ladakh and LAC in some newspapers. How do you think that those things are available to you? Who has gone? No photographer has gone. No journalist has gone. No newspaper can go. A person can go there. It is all clad with snow. It all, you cannot see even 50 to 10 feet what is happening. And the temperatures are below 40 degrees, minus 40 degrees. So in such situations, how do you know? How are they publishing? Our advisories are vacating the place. Are they not vacating the place? Are they spelling lies? All this done with the terrain mapping of fields by what is called the synthetic aperture radars. Synthetic aperture radar gives a correct picture of what is the position, as if you are seeing with your own eyes. So this has become very, very important in terrain mapping of hills, and it is very useful for our planning of our most of our construction of projects, construction of bridges, construction of dams, things like that. It's not possible to just take a photographs, normal visual photograph. We need to take the photograph using the synthetic aperture radar for terrain mapping. So if you see here, this is how a cyclone is seen in a radar. They will, if you see the center of this is called the center, the eye of the cyclone, and this is all peripheral things that you see. The intensity, red indicates intensity, at what speed the wind is moving, and these are all the other the places where the rain is happening. So therefore, it is giving us a forewarning how the cyclone is moving, and when and what time they are going to predict accurately at what time a particular cyclone or a storm is hitting a particular coast, at what place it is hitting. Even the tornadoes, which are normally very common in US, are being tracked by this kind of radar. Okay. Then when we come to the military applications, there is nothing other than radar. Then many of the students, if they want to join Army or Navy or Air Force, 80% of their equipment are nothing but radar. And this radar is used for not only for finding out the countries, protecting our country's borders, and it is not only able to navigate our military aircraft in naval ships in difficult, unknown places. It is able to also tell us whether an aircraft or a missile or any other drone or helicopter is coming on to our land for releasing the bomb, or what is called called the strafing. It is called the strafing. So if somebody aircraft, fast tracking aircraft of our military, of our advisory comes to release bombs on our parliament, Rashtrapati Bhavan, atomic stations, military installations, then the seaports, airports, who will know? Who will protect them? Who will protect them? What are the equipment that is able to protect these things? This is done again by the radar. Radar tracks a particular object, moving object. It will also tell you whether it is a friendly object, friendly aircraft, or a friendly airplane, or it is a hostile aircraft. So based on that, you can engage anti-aircraft guns, or you can engage surface-to-air missiles, guided missiles, so that these hostile aircraft, which have got bad intentions, can be totally annihilated in air itself. And that's how we have the total protection of all of our installations, important installations like our parliament, as I told you, Rashtrapati Bhavan, then other nuclear installations. They are very, very important for us. Fortunately, you students have not seen how devastating will be the war. We are only talking about COVID, thinking that COVID is very bad. We are not allowed to go out. But when a real war comes, it will not only suck your family. So many people will see that so many people from your society will be killed. It's a very horrible situation. So something we had to spend. There is no other go spending a huge amounts of money on the R&D. That is how the DRDO came into picture. So it is no point in keep on purchasing the military equipment from abroad. At any time, they can stop the space. They can do not give the required technology. Even if they give the required technology, they may not. They may hide something, some defect on this. Okay. When we talk about this military radars, which we come to this, which is called the tracking radars, we will come to this in a very elaborate way. What is this tracking radars? How they are operating? So the very famous radars, which are now being used by the military, it's called the multifunction radars. It is not that a radar cannot see all through the beams. It is not correct in the sense that today's multifunction radar will see the whole 360 degrees because of the electronically scanning radar. They call it electronically scanning arrays. They can engage our aircraft, adversaries' aircraft in large numbers when they come to bomb our places. So this is called the phased array radar. They are passive synthetic aperture, passive phased array radars are there, active phase radars are there. Their radar has developed into a very, very sophisticated field. Then the very famous system, which is called the Patriot Air Defense System made by the radar, it's equivalent to our Akash missile. Unfortunately, fortunately, I am the person who have involved integrated this Akash missile. It's a very deadly missile, and you can see Patriot missile we are not given because of the complexity. But thanks to our Dr. APJ Kalam, we are able to, under his kind, the persons like me, who was the chief of the integration of all this Akash missile components, radar, then launchers. Now it is protecting our eastern borders, and it is said that it is very, very effective. It's very, very efficient, even compared to many of the Chinese missiles. Chinese don't have an equivalent of this particular Akash missile. And for your information, it's not a small amount you have to spend. If you want to purchase a TV or a mobile phone, probably you will go for 1 lakh or more. If you want to deploy a 10 Akash missiles, even in a limited area, each Akash missile battery costs around 6,000 to 7,000 crores. So if all our border has to be protected on the west and also the east, you may require thousands of these Akash missiles. So poor country, it's when compared to the other countries, can be afraid, can be afford this. That's why we are able to safeguard only a limited space with this Akash type of missiles. Thanks to Kalam, who may be there in heaven. For him, as a countryman, we should bow and pay our grateful respects to him. Because of him, we had the Akash missiles. Because of that, we are confidently now sleeping in our houses. If really Chinese wanted to occupy our positions, and today we are not in a situation where it was in 1962. They are afraid now. They are thinking twice to do something against us. It's all because of the technology, which is all because of many technologies, weapon control radar, which Kalam has in his tenure. That was a very, very useful equipment which Americans refused to us at that point in time when we wanted, but we developed under the guidance of Dr. APJ Kalam. It tells from where a shell is fired, location accurately it gives. So if the location is known, we can fire our anti-artillery ammunition onto that particular place instead of firing blindly into a large area. So my once again emphasis is that the main the main complexity. I'm not talking about the smaller techniques and technologies, VLSI technology. I'm not talking about your microprocessors. They are all integral parts of the radar. They are being used there to get some kind of equipment functionality. So radar is a complex thing. You can't say that a VLSI man will do a radar. A VLSI man, a mechanical man, a micro man, then a signal processing man, all this a control man, all these people together have to sit together and make a good working radar, which is whether it's a civilian radar or it is a or a civilian or a military radars. Military radars are much more complex and costly because of so many other reasons, which we will know later in course of our course. And the Cobra Dane radar, which was designed by Uli Brückner. There are three people, since we are talking about the radar course for 30 hours, we will be going into the detail, many of these fundamentals. Cobra Dane radar is a waveguide radar designed in so many years back, and the design started a long time back. It has resulted in keeping this radar and trying to detect the Russian missiles, which are even if the distance is more than 10,000 kilometers. The main designer is one person, Yuri Bikra. There are three great people in radar. You should remember those names. One is a Skolnick, who has written this beautiful, beautiful books on the radar. Number of editions have come. The second man is a partner. He gives us the total insight of a design, mathematical equations, the algorithms he has gone through, is Barton. Third is the hardware man. He combined this knowledge into making the hardware. He's a Yuri Brigada. Fortunately, somewhere in 1982, he came to Madras at that time under the IEEE. IEEE arranged for a 2-month course. I was fortunate to learn under him for every day 6 hours for almost 2 months. Cobra Dane. He explained about the Cobra Dane radar. Is Yuri Brückner. His name is Dr. Yuri Brückner. I don't know whether he's at that time itself he was around 80 years or so. Definitely he wouldn't have been here now. Anyhow, that is the state of the radar. Why I'm telling you is the intention of starting this course is for the students are not aware. Unfortunately, teachers also are not aware the importance of the making a hardware system. Most of our universities are unfortunately give the techniques and technologies. The reason is that the teachers themselves have not worked in the industry. So unless the teacher goes into the industry, stays there, knows their methodologies, finds out what are the requirements, come back to the university where the best brain students brains are the best. They are not polluted. They are not polluted. Many of the inventions came, best inventions came when the students are at a most young age, the age only. So then you may ask, what is that our country also doing? Unfortunately, the industry, the commercial industry is not picked up in India. But whereas military radars, we have large number of radars developed by the DRDO. I will show you in course of my slides the Indra radar, the Rajendra radar, which is used. The Rajendra is a map. We have put this name under his caption, this radar, because he was the designer. He unfortunately died in the course of time. So therefore, we call him the Rajendra radar, which is used in the cost sites. Then we have developed a lot of latitude surveillance radar, the naval maritime radar. All these things, DRDO develops a technology, builds it, make it into a product, make it into a hardware, make it into some kind of a workable model, test this under the hardest conditions of the military environment. Military environment, there are no roads, there is snow, that so the temperature should be going up to minus 55 and high temperatures going up to 60 plus 60, and this equipment had to work. So therefore, there's special care in the technology techniques that to be used, and it's a very costly position. Now, I will take 10 to 15 minutes more. This is seen as one of the great example in the Second World War. So let me say that this is actually a German aircraft. This is a German aircraft which is trying to come to London and release the bombs. It's called the bomber. Now, how do you destroy them? This when it enters on the zone which is called the radar will have a zone, that is the surveillance zone. When it enters into the surveillance zone, it is picked up. The approximate coordinates of this, right from 200 to 250 kilometers, will be passed on to a tracking radar. This is the tracking radar here. So as the tracking radar range will be less, let us say it is 80 kilometers or so. So once the aircraft enters into this particular zone, so what is done is that it is tracking this particular antenna, is continuously tracking this particular radar. The accuracy of tracking will be 0.1 milliradian, that is 0.0057 degrees. That kind of accuracies are required. I will tell you later why it is required. So then what they do is, this antenna position through control systems are linked up to all these AAA, anti-aircraft artillery guns. So they start firing in the direction. So once they start firing in this particular direction, when this ammunition reaches there, which what is called the proximity fuse, they explode. There, so that when they explode, because they carry a small amount of warheads, this causes the damage to the aircraft. So this was the technique that they were using in the just before the starting of the Second World War. But it was not 40% of the aircraft were being shot down. But then 60% used to escape, because by the time this ammunition reaches the aircraft, they moved or it made a maneuver. So therefore, the missile systems are designed. So the rocket is fired. A rocket goes in the direction as the target maneuvers or changes its direction. Pilot keeps on changing its direction to escape being shot. The missile guided from the ground. That's called the surface to air missile. When it is guided from the ground, you have to know the position of the track to this particular target, also the position of the missile. So once you move, the requirement is to see that the position of the target and the position of the missile is same angles. So three-dimensional azimuth, elevation, and range. To keep the missile in that particular position, we need guidance. That is where the surface changes are come. That is where the additional function of the radar comes to play. Command guidance radar. It's called the command guidance radar. So when you have that kind of a missiles like the Pursuit missile, Roland, Cortez, used by the British people, exocet missile used by the French people. So what happens is there is no escape from for the aircraft to not being shot. The probability of kills is go more than 99%. So you can imagine what difference is there between using a artillery gun, a gun, or a guided missile. That is how the technology, missile technology grew. And the heart of the missile technology is the radar. The heart of the technology is the radar. Okay. Then, coming back to the students, many students ask, where do I get employment? Okay, you are not reading, you are not studying radar for whole of your course. It is only gives you an opportunity when you attend for the to the interviews, you will get edge over the other people if you have studied the radar course. It's because Indian Armed Forces, I told you, Army, Air Force, Navy, 80 to 90% of their equipment will be using radar. If you answer one or two questions in the radar put by the interview committees, they will love to take you. Similarly, DRDO labs, DLRO, LRDE, DRDO, RCA, they are all work based on the systems developed, missiles developed, equipment developed, all uses the radar. So radar is, if you study radar, you are going to be at an advantage. Similarly, Indian Space Research Organization, this also uses the radar to locate the position. Somebody told GPS will give you the location. Unfortunately, GPS will not give us the location. It gives the location, but not to the accuracy in which we are interested. We want accuracy to the tune of centimeters. Tune of centimeters. If your vehicle is moving, if you cannot locate your vehicle, another vehicle which is ahead of you within a distance of less than 10 centimeters, then what it will do? It will not be functioning. So radar again becomes a necessity. So ISRO, they learn so many factors. How do you communicate? How do you know where it is? Can you see with your eyes? You cannot see with your eyes. Everything is cloudy. Everything distance makes our vision. We cannot see it more than 2 to 3 kilometers in some site. Then the most important department in which radars are used, only radars are used in Indian meteorology department. There are a lot of job opportunities. Today, government wants to establish these radars across the whole of this coastal. So we are not able to do this because of the money. But as we progress, we will get more and more money. So people should be there. The engineers should be there to man this radar, maintain this radar, study this radar, bring in new radars. So you have got opportunities in the Indian meteorological department. Third is the automobile. I did not have to stress. I have been telling automobile industry, the major industry, is going to employ engineers. If that is the case, then you want a radar engineers. Today, education policy, if you see that that we want no specialist. We don't want a specialist in the computers. We want the specialist in ECE. We don't want mechanical. We want multidisciplined engineers. That is the education. Our education policy is laying stress on multidiscipline. That is, tomorrow, maybe from 5 years from onwards, you need to apply only for BTech. And you can choose a subject in PCB, you can choose a subject in civil engineering, you can choose a subject in automobile or space science or anything, and all of you will be called as engineers only, depending upon the necessity of the industry. There is nothing like specialized and specialized in ECE and specialized in civil. All that jugglery is going to disappear, and depending upon the industry's needs, and we need to be not only expert in one field, but you need to learn other sciences or technologies also. If you are designing a radar, probably you may have to know also certain science like how to make it, how to make AutoCAD, how to use AutoCAD, how to make a chassis for the radar to be put. So all these things are there. Another great employer is the shipping corporations. Shipping corporations do a lot of money. It's a particular engineers there. They're staying for 2 months, 3 months. So they need a lot of this radar people, because I told you the ships will carry the radars. Then we have opportunity Bharat Electronics Limited. Bharat Electronics Limited, which is having 7 to 8 places of factories. It is the biggest electronics PSU, that is public sector unit, which is taking this manufacturing industry out to sell across 1,500 to 1,600 crores in radar alone. So you have a lot of opportunities there. Then Electronics Corporation of India, they also use a lot of this, develop a lot of this sciences, especially for the atomic people and ISRO, and private industry like Astra Microwave, Avantel, they already existing large industries like LLT and Tata are entering into the military industry, and once they enter into the industry, putting their capital into that, they need a lot of engineers. Plenty of opportunities in abroad. I told you, presently, India is at the bottom. You have a lot of opportunities if you want to work in abroad. Companies use radar engineers. Then lastly, in the gate examination also, the subject will help you in giving you a good score. So this is what I want to tell the students who have come here for today. Today, to give a glimpse of what is happening. I will not go into the details because time is not there now for this first session. I will just keep moving the slides to see how a radar look like, Okay, radar is what is a radar? It is based on the acronym radio detection and ranging. So they have taken two letters RA, they have taken this B, and they have taken A from and R from range. So it gives a detects and ranges a particular object. Okay. So this is I will give some photographs of Ave and our Sagara has told. This is the man who saved England from the German onslaught. I will tell you in detail what happened because only radar only have been invented at that time by this particular man, 1920s and 1990s. It's called chain home radars. It's he held in great respect in England. His name is Robert Watson, Sir Robert Watson. Watt. That was a watt. It's also, you know, what is a watt? Then in honor of this, our one of the electrical units is named as watt. So this is a chain home radar. It protected the British coast and saved Britain, and that's how German was defeated in later times. So this is how bubble you see, no? Any aircraft that was entering into that bubble was seen by the chain home radar. You have got a lot of these spots there where radars are located. This is the photograph of the radar. This is the military radar. This is the police radar. To find out what is the speed of a vehicle. Later they will find out and challan you if you are exceeding a particular speed. And not only that, this is the radar which was gone into the NASA, the first land rover. It's called a rover, land rover. It was put on the moon's surface. It is trying to guide itself by the radar signals. Okay. This is early warning radar system of Russian system, the another Russian system, and as I told you, how this particular antenna, World War II defense system was there, and this is tracking radar, which is called the Sun-6 radar. We have in India, we have this kind of a radar, and this is our radar, which is developed in Bharat Electronics. It's called the Indira radar. Long time back, it can detect targets of 500 to 600 kilos. It's meant for the Air Force, and this is the Rohini radar, which we are using as a surveillance radar. We control by the battery surveillance. It's called battery surveillance radar, the Akash missile, and this is actually the power Akash radar. It's called the agenda radar, and it's a phased array radar. There are so many elements there. We'll come to that, what is the function of each element. Today it is protecting our eastern border. And this is the Cobra 10 radar, which we have imported from the Israelis to locate any Pakistani missiles. This is located in Bangalore near Kolar. It's under a very strict classified. Not many people are allowed to say this. But when I was director, I happened to see this radar, and we have paid almost $2 billion to acquire this radar. Two of them are acquired by our country. So these are all some of the radars you have seen. Some of the airborne radars, and I also told you airborne radar is a must for any aircraft, whether it's a military or a civilian, because once you are flying, you do not know. There will be a lot of air factors, a lot of storms. The pilot can take your aircraft into that which we are flying. They are not able to see anything. So the aircraft forewarns the pilot, and he will avoid those places, localized places, where these air packets or storms are there. This is again the Cobra 10 radar. And coming back to radar frequencies, I'll come back to this. Not all frequencies are allowed by the general society to use by the military. So this is how it looks situation. A place where you have a large number of these radars. Not all radars are radars. And this is the types of radars you have: Doppler radar, police radar. Then this is when there is a storm or a cyclone, which is enclosed in the radar. This is how it looks in a display. By using the digital signal processing, digital NPI, you can remove the storm. You can see clearly some of the targets there. tracking radars, which are mainly meant for the military. Some of the techniques which you see here, you will learn. There is a separate chapter also on this. Then advanced radar technologies, phased array radars, I told you, what are the principle of this we will learn. Nowadays, it is when you are using a military radars, the military wants that their aircraft should not be detected. So for that, they go for low probability of intercept radar, things like this. Okay, we are all going to learn because we got sufficient time. Bistatic radar, active radar, then millimeter radar. This is used especially in small toys. Small toys. This can use this even 1 to 2 millimeter range. To that accuracy you can go because they're using the millimeter. How it should be done, we will learn later. Then over the horizon radar, weather radar, you see, then you see the SSR, ISSS radar, the synthetic aperture radar. Just I told you how the photographs, radar photographs give us the actual picture in places like in the terrains or in our borders where our forces are. If you see with the radar, how clearly you can see it's a synthetic aperture radar image of a golf course. So clearly you can see from a distance. And this, you can see this picture, you will see even if there is that particular area is covered by cloud, by rain, or by haze, whatever is there. Because radar penetrate. And as I told you, this is synthetic aperture radar mounted on a satellite, and it gives the how a particular hill, how a particular surface of the hill is seen from that particular radar. Okay. Okay. Now, thank you very much. Since it is already 12:30, I would like to end this. And from tomorrow onwards, we will start our course as per the JNTU syllabus. Okay. If there is any questions, I would like to answer if I know. Okay. Adila,
thank you, sir.
I am completed. If any questions are there, you can.
Yes, sir.
This conference is no longer being recorded.
Participants, do you have any question? Please ask to sir. If you are seeing on YouTube, you can paste your question on the chat box of YouTube.
This conference will now be recorded.
Hello. Hello.
Yes, please.
This conference is
Sir,
no
this is-
longer being recorded.
Yes,
Hello?
please go ahead.
Sir,
Yes, yes.
sir, how the SAR radar is being used, sir? Synthetic aperture radar.
I will explain to you in our fourth chapter. In the fourth chapter,
Okay, sir.
see how it works. When you, because it is the syllabus in this, the principle is like this.
Okay.
It's normally synthetic aperture radar is mounted on aircraft or satellites.
Okay.
You take a, let us say, aircraft movement, it is stationary. You take a
Yes, sir.
radar photo snap of that particular area. Okay.
Okay.
Then you move particular distance. Let us say after some seconds, you have moved by some 10 feet or so. Again,
Muted.
Yes, sir. Some existence.
radar snapshot out of that. So
Okay, sir.
this you keep on keeping the snapshots. If you are a
Okay.
micro expert, antenna expert, you know that
Okay.
the antenna size increases, the accuracy of the location increases. So
Okay.
all
Okay.
this that is antenna size now is not a small one, since the radar has moved, let us say, 1 kilometer. So you are
Yes,
got
sir.
a virtual antenna of around 1 kilometer. So when you have got a virtual antenna of 1 kilometer, the beam width will be very, very small. Okay. So there is this algorithm, complex algorithms are there which will solve these things so that you will get a very finer fiberitic picture of the particular object from which the echo is coming. Synthetic aperture radar,
Okay.
it's a very, very, the radar has to be mounted on an aircraft moving platform, either on a, let us say, on a UAV or a drone or a satellite. So that
Okay.
unless it is moving, you will not get that kind of a solution. Okay.
Sir, did Indian system has a defense system has this SAR radar, sir?
Yeah, ISRO is doing a lot of work on ISRO with this synthetic aperture radar. They have already developed
Okay.
some radar. They are using them. They are using them. So the pictures you have seen on the Ladakh border, which have been published, is thanks to ISRO, transferred to military. Then military has published those pictures there. So synthetic aperture radar are very much there in our country.
Okay. Okay. Thanks. Sir, generally I work for the BEL, sir, at Jammu.
Okay.
Hello. Work
Welcome.
for the
Welcome.
Jammu Air Force. So
Yeah.
just I want to know that because I have in my engineering in somewhere in 2002, Professor Gogineni, you said that SAR radars are the first used in the Iraq Kuwait war by the US.
Yeah.
But I was very much interested to how it was really work.
Yeah. The principle is increase the antenna size, then the
Okay.
resolution increases. It is virtual.
Okay.
Virtually, you are moving the radar antenna by means of aircraft.
Yes, sir.
Take snapshots, then merge all those things using a complex algorithm. That's how
Okay.
they can do it.
Thank you, Prashant sir.
Thank you, sir.
Thank you, sir,
Okay.
for active participation. Sir, few other questions are in the chat box. The first one is that will we get enough practical knowledge by the end of the session so that we will be able to build our own radar system? Is
See, this question, whatever we are studying in this 30 classes are only fundamentals of the subsystems that are being used. Second thing is that many of the subsystems, which are now under the curriculum, is not in actual use because technology has gone further. Technology has gone very further. But the student will get the fundamentals of this. 8085 processor, fundamentals. What is the memory? What is the processor? So these things, we never use 8085 in our commercial gadgets now. So our intention is to know the principles. Once you know the principles, when we go to a place where you are employed by the industry, where sophisticated radars are being manufactured or maintained,
And one more interesting question is there. Does satellite has the radar system? I think obviously to communicate with the satellite, we have to be radar earth station. Am I right, sir?
In giving this such a long course on online, that too free. So therefore, it is only for the benefit of the people who are now trying to learn something about this radar and then use this for their thing. Okay. Okay.
One question is coming from the audience like that. Can we learn ECM and ECCM and radom in this course?
We will not learn about EW. See, the enemy for this particular radar is the EW. So EW is not is a rival to radar. So therefore these two technologies are go parallelly. They are enemies. So therefore, if you want to learn EW, you should know what is a radar. So when I joined the EW lab of DLRI, my concentration was I had to apply my EW on this particular radar. So therefore, my requirement is only to first to design a EW system. The knowledge of radar is most important. What it can do, what are its deficiencies. Then I can design an EW system, ESM system, or a ECM system to overcome the whatever facilities or whatever technical specifications, what are the capabilities of this radar. So in a war, it's always a enemy to enemy. Radar engineers and EW engineers have to devise one over the other. So these are the rival technologies. These are the rival technologies. When you design a low probability of radar by the radar engineers, the EW engineers need to devise an equipment which can also detect a LPA radar. So that is the rivalry. That is the technology going. Okay.
Okay, sir. And now I think I will take the last question. That one is can you give me the example for radar uses in medical field?
In the medical field, it's really you see most of the frequencies that are used in medical fields are beyond millimetric waves, because they have to design, they have to come out with the tumor. So the frequencies that are used are very, very high compared to the radars which are meant for detecting targets and other things. So the 95 gigahertz frequencies, even go beyond that particular frequency, people are using them for mapping the body. So therefore, normally when they say send a probe inside our body, then what happens is that the echoes that it emanates the signal, the echoes are picked up and through a cable, it goes to a signal processing unit and then converted into a visual display. This is how the things are going on. There is always this problem of using this millimetric wave. People have not still mastered this technology. So very advanced countries only have devised this equipment, medical equipment, using this very high frequency radars, very high frequency radars.
Thank you, sir. Now, I hope all the participants have some knowledge about the radar systems and they have clarified their doubts. And I hope we all are very blessed, sir, to get a knowledge. We are getting the knowledge from you. We are able to learn something from you. And we have a long 3 days schedule with you, sir. And I hope we will learn very much from you. And sir, also given us some what is the radar application and the job opportunity in radar for our students. So all students must be benefited with this course. With this word and with your permission, sir, shall we close this in this class today?
Yeah, we
Now,
will take this class. Tomorrow we'll start at 11 o'clock.
yes, sir.
And it will start with the regular JNTH course. We will comfortably, there are 5 units there. Each unit we will take 5 to 6 classes. Then they explain the systems, subsystems, principles. Wherever a bit of mathematics is involved, it is it may be difficult for me to project because there are some lengthy derivations like noise elimination, signal processing, correlation, autocorrelations, things like that. It will be only good if it is explained with a chalk and on board, blackboard and chalk. Such places I will try to quickly go through, and those things which are very few in number, those things when you really attend your classes, the teachers there will try to explain. Okay, especially the noise elimination problems where a lot of where a lot of mathematical algorithms are involved. There we may have to go in a broader sense. Okay, the rest of the things I will try to explain in such a way that I will not leave any principle untouched. Okay, and
Okay, sir.
most of the syllabus is based on the American mm, uh, course of technologies. Russians do not use the normally the American or European technology. They have their own way of making the radar, and their radars are also very famous. And it is said that more than the European radars in military radars, Russian radars are there. They are supposed to be very rugged and more reliable compared to the European radars. I had the fortune of studying in Russia, thanks to Dr. Kalam, who sent me there for our missile program, Akash and Kushil missile program. I have also undergone the French radar, which is called flycatcher radar, thoroughly. A long time I was asked to study that. Based on that studies made on the, we were able to design all our missiles, Akash, Kushil, then Prithvi missile, Nog missile, then cruise missiles like BrahMos, air-to-air missiles, Astra missiles. These are all now operational. They become operational. Okay. Thank you very much.
Yeah, thank you, sir. Now all the participants are requested to rejoin us on tomorrow at sharp 11 a.m. And I would request you to Sankara reddy sir, please close the session now. Thank you, all of you. Thank you for your active participation.
Thank you, sir. I am closing the session. Okay,
Yes, sir,
thank you
please.
all participants. Tomorrow, please join. Okay, 10 minutes before.
It is on this particular platform of learning, because learning is a skill we should keep on continuing. Thank you all. Thank you all.
Thank
Over
you,
to you, Abhishek.
Professor. Yeah, thank you, Professor. Thank you for your interesting introduction about the radar system and invocation address to the gathering. Now, I would like to take the opportunity to introduce Dr. Ram Babu, HOD ECE Department, VIT. And I would like to extend my invitation to Ram Babu sir to address the gathering. Welcome, address the gathering. Dr. Ram Babu sir, please.
Thank you, Abhishek. Yeah, I'm audible. And they have presented the work practice
Of ECE
Dome, and also they use the sonars, that is
This is not correct. This is not correct. To the radar. Main to keep the missile in that particular position, we need a guidance. That is where the supply chain missile comes. That is where the additional function of the radar comes to play. Command guidance radar. It's called the command guidance radar. So when you have that kind of a missile, like a Pursuit missile, Roland, Cortez, used by the British people, Exocet missile used by the French people. So what happens is there is the military craft
Yes, sir.
takes here you should so radar will explain to missiles with anti-collision radars are mounted on the trains. We have seen the picture Titanic along with that love story also is there. Almost 80% of the population, especially the students, would have seen this particular picture on Titanic. So the Titanic ships at that time was built. It is a luxurious ship. It was built at that time. There was no radar. So therefore, unfortunately, this ship traveling through a storm goes and hits an iceberg. Icebergs are the islands where ice is formed. The person driving will not be able to see. So it went there and got this total destroy was there. So many rich people died. It's all happened because at that time there was no technology, there was nothing known about the radar. Radar came into picture only in the Second World War. I will tell you why, how it came into picture later. Then another important thing is today we keep on looking at the weather. Should I go out? Should I go in car? Will it be raining? Or Do I get sit into the storm? All this information, who is giving us? When you open your mobiles, you will see the weather report. When you talk about see with the TV, they will tell you. When we talk about the cyclones, when we talk about the storms, where they are going hitting the coast, this is required for our revenue people so that they can evacuate people from being killed by the storms or the cyclones, so that at least life is preserved, life is a endangered life is preserved. In probably you may not be knowing that long time back when N.T. Ramarao was our chief minister, there is what is called a big cyclone came. Uh, thousands of people died. It is called the Dibisima cyclone. It was all because we were not having any prior knowledge of where the storm is going to hit. So from that time onwards, we have all the coasts, all our coasts are equipped with the weather radars. Then today, agriculture also is monitored. The crop monitoring by pests, weathering, etc., are done by the radar. It's a complicated type of science, but radar is they take the radar pictures and try to predict and give the necessary warning to our government people to use whatever pesticides are there, things like that, and give it to the advise the farmers. Then coming back to the last but one, this is the height of aircraft, very, very important, and helicopters are today flying in large numbers, especially the helicopters also. In European countries, helicopters are manned by large number of private companies. They should know the height of this helicopter when they're flying. This height of the aircraft is known by what is called the radar. It is called FMCW radar. It's called a height finder. So, to give of course, a tragic example, our Chief Minister, Sri Rajasekhar Reddy, untimely death is now attributed, it's found that it is attributed because it's the helicopter in which he was traveling, the altimeter was not working. And he was flying in a Nalamala forest where there is a lot of hills. It was raining. It was totally dark. The pilot could not, the helicopter pilot could not see what is happening.